Ready now. I don't know why. It seems to work the best in Internet Explorer, even though it's a Google product. I don't know why that happened, but when I started up the presentation, it died in Google Chrome. So did it in there. All right, so I posted material on Blackboard. Thanks for coming, everybody there up there in Hattiesburg. Now you know how the people down here get it every week. I will usually be in Hattiesburg, but I'll try to come here more often than I have in other courses, because there are so many of you. I took this opportunity because I came down to the coast actually to take a test. So I knew I knew that I had to take it sometime, and I decided, hey, if I take this on a Tuesday, I'll already be down here and be able to teach from here. So it's nice to get to see you face to face, because it's easier through there. Now, I had everybody else tell me their name one more time. Brady. Okay, great. Just so I can make that connection face to face. And you know, I'll be here. Usually when I come down, I'll try to be here in advance. I don't know if that'll help if anybody wants to give a talk, I mean, to ask questions. I know that after class, I'm also available for questions, but I know when it's getting close to 9 o'clock, that's probably not the best time. So it might be better beforehand. It's also I'm also fine afterwards, but you know, if you're coming from work or whatnot. But when I do come down, I'll do that. And of course, I'm always available by email. So today, what we're going to do is kind of continue where we left off last week. We're going to go into a little bit more detail about the architecture, the way that you would, in terms of what computers need to do in order to run web mapping software, and how those computers need to be set up, and how the computers talk to one another. Okay. Now, this will probably continue to build on and make more sense as we progress throughout the course. But today we're going to go into a little bit more depth. The other thing that I'd like to do is, during the lab portion of the course, introduce the assignments for today, and also something that I said I was going to do this week is just give an introduction to HTML in general, because next week is when we start actually building our first web map, making our own web map from scratch. And so at that point, it's good if we know some of the basics of HTML. In this class, I don't know how many of you have taken a cartography course. Probably a lot of you if you're GIS majors. But even if you're not, cartography is the study of basically how to make maps more effective by making them more visually appealing, and making them or helping to make them communicate the message that you want to get across. And that's different than like a GIS class where we're really focusing on analysis. And so I want you guys to, maybe I'm just like managing expectations here, but you know, there's a lot that goes into web design. And this isn't a web design course. Like we're not gonna learn how to make the most beautiful web page in the world. And I'm sure there are courses here on campus that teach that kind of thing. But we're going to learn a little bit more about the functionality. So at the end, and this is one of the requirements for this course, is that you make a web map that's functional. Your web map may be very functional. It's going to work. We're going to make sure that it does that. But your elements on your page, you know, may not look like it may look like something out of the 1980s, and that's okay. So we're not teaching that aspect too much in this class. I mean, I'll give you some pointers and tell you how to explore more and how to lay out a page right. But you know, a basic web map, you can still make it look pretty good without having a lot of bells and whistles. But you know, what I'm talking about are you know, fancy layouts, putting things in interesting places on the page, and also like fancy transitions on web pages and things like that. Okay, we're gonna be basic. All right, but I'll get to that later. So we're gonna do things in that order that I talked about. First, introduce the material that we're going to talk about today, talk about it, then go over the lessons, the assignments for today, and then finally do the HTML overview. And as I said before, typically we won't be here till 9 o'clock, but we'll be here somewhere between 8 and 8:30, is from what I imagine. Okay, so what I've done is created. I won't do this for every lecture, but again, I've created like there's no textbooks for this course, so I've created like a reading, and I've gone ahead and opened that. That's right here. Okay, got the reading open. I'll refer to that as I go throughout the lecture. And I also have, today I have some PowerPoint slides, but these PowerPoint slides are not an entire lecture. They're just for reference, because I'll be using these figures. A couple of the figures are in the readings as well, but we're going to make them larger. Okay, hit that. I don't even think that I'll actually go into the formal slideshow mode. Just leave it at that. Okay, I think everybody can see that, or everybody can download it on their own computer and look at it. You don't necessarily have to view it on the big screen, but when I point to something like this, you'll be able to see that if you look at the big screen. Okay, so first of all, everybody can hear me in Hattiesburg okay? Great. What's that? Oh, okay. Yeah, that's a good idea. Let me do that really quick. And then we'll get into this. So it's like an earthquake going on or something. Is that I'm sure it's not an earthquake. I was joking, but I'm from California, so I don't know. On this one, it's not giving me an option to like zoom in, but you can see me all right, right? Yep. Yeah. All right. Okay. Hey, Garrett, how's it going? You still don't show up as being enrolled in the class, I don't think. I mean, it's fine if you're here, but I just want to make sure that you know that. Maybe I'm wrong. Okay, let me look really quick, because that would be not good. Self-service. Oops. So you'd be enrolled in the Hattiesburg section of 490. Yeah, I guess you're there now. Sorry. Yes, you're there. Good. Okay, we're all set. All right. So I wonder what did create. Was that just shaking? Yeah. Oh, the train. Cool. I used to teach a lot at Stennis, and sometimes the rocket tests would cause that. All right. So this is what we're going to talk about today. We're going to talk about all these individual components. Now, most of the time, when you're setting up a web mapping environment for either for something like we're doing in this class, where we're not trying to scale things up, we're not creating a web page where we know that thousands and thousands of people are going to be there. All of these things that are shown on this graph, the web server, the geospatial server, the database server, the file server, those are actually the same physical computer. They don't need to be separate computers in order for in a web mapping system. And in fact, oftentimes as your system grows and expands, they become separate computers. But at the beginning, they're they're all on the same computer, and there's several advantages to placing them on different computers, but that's easier to describe once we talk about what they do. And I know that we showed this this a little bit. I think we showed this exact same diagram last week, but we're going to follow through each one here. So the first thing that we're going to talk about, and I always struggle which one to talk about first, but in this time that I teach the class, the first one we're going to talk about is this web client applications. Okay. Now, strictly speaking, a client for an internet mapping or web mapping server can be anything. Okay. Remember last week I said in this course we're going to use your web browser mostly, right? But you can actually use something. Usually they refer to it as a thick client. You can use a desktop application like ArcGIS to access internet maps. Okay. Who's done that before in this class? Anybody done that before? Okay. It's becoming more and more integrated into the experience in ArcGIS, actually. I'm going to open up ArcGIS here real quick to show you what I mean. And maybe you have done this and you just don't realize that you're actually accessing an internet map server. So if you hit a drop down here and you choose Add Base Map, the base maps that are choices here, those aren't stored on this computer. Okay, they're not local base maps. These base maps are all online. So if I choose something like this dark gray canvas, maybe you're not familiar or haven't used this before. This is a base map that gets commonly used for bright symbols. So it doesn't stand out. I'm just getting that message because I'm hooked into the projector. If I wasn't hooked into the projector, it wouldn't complain about that. But it's basically saying your projector isn't the highest quality display device. Ooh, that looks really bad. Can y'all maybe if you opened this, that's probably why it gave me that message. Here, I'm going to do one that's lighter. So the dark gray base map basically just showed the land as dark gray and the water as almost black, but another dark gray color. So I'm going to I'll just hit new, blank map. No. But anyway, who's done this before and just didn't realize what I was talking about? Yeah, okay. So you've all done that before. Down here, everybody up there added those base maps, right? Okay, cool. So these are actually the same base maps that ESRI allows you to add to your web map. Okay, and so I won't demonstrate that again since it seems like most people have done that. You can also add regular data. Maybe I will because then we'll add some regular data. All right. See if that works. Yep, looks good up there. All right, so that's the oceans base map. This is a base map I use a lot because I do work in the oceans in the Caribbean. So I use that a lot on my web maps. Here's another thing that you can do to add data from a existing service. This is add data from ArcGIS Online. Now, by default, you can add some data without signing in. For example, maybe I want to add the coffee maker ownership map here. Oh, I was wrong. It does look like you have to sign in. Now, there are free accounts, and lots of this data is available as a free account. I can get you an account that gets you a little bit more access if you're interested. But you can sign in by creating on the ArcGIS Online by creating a username and password. I remember my password here. I've added the coffee maker ownership map, and it should show up here in a second. Depending on your internet connection. And there are lots of data sets that are available, and this is often okay. This is often sorry, I should make this a full thought. Using a thick client like this, and what I mean by a thick client is that it's actually a program that runs on your device. Another word for it is a native app. Okay, it's ArcGIS is a native application for my computer. Okay, but on a handheld device, a native app would just be something that actually runs on your computer. Okay, but it's still accessing information that's served up from a web service, usually off device. Okay, sometimes that's actually starting to blur in some respects. So both the thematic data layer and the base map are like that. So, and you notice that if I zoom in here to Mississippi, I'm going to get more information. Okay. All right. Anybody know how to do that in ArcGIS? What I just did, like what this website does? Have you done that in ArcGIS before? Basically, you're setting up a what happens in the MXD? Do I have an MXD that has I have a layer that represents, no, that's way too far out. But here I have a layer that represents countries. And when I zoom in, it hides the layer that just shows countries, and it shows the layer that has states, and it hides the counties. And when I zoom in further, it hides basically all those larger units and just shows the counties. And as I zoom in again, you'll see that now I'm just showing zip codes. It's one of the things that is true about most GIS server software packages is they're actually not running any code or any program that you're not familiar with. We'll see when we get to authoring services like these. What's happening is that somebody created a map document and chose what colors to put on the map, chose what you see when you zoom in at various levels. They chose all that information, and they saved it as a map document. Okay, and then when that is added to a layer like this, when it zooms in, it changes automatically. You can see these are all the layers in this map document. Okay. Now there are some things I can't do because this is a web service and not a native. This data set is not loaded locally. For example, I can't right-click on these data sets and say open attribute table. That's something that you can usually do in ArcGIS, right? What does that do when I open the attribute table in ArcGIS? Yeah, it has the attributes. Okay. Now, depending on how they've set up this web service, if I use the information button, I can still get some of that same information. Looks like that didn't show up. Visible layer. Click on this guy. Still no identified features. So they must have set it up so that it actually does not allow for that. There are ways that we'll cover when we get down the road a bit, but there are ways to set up a service to allow and identify. In other words, to allow a spatial query. So basically, you send a request through the internet that says, "Hey, I want to know all the attributes at this particular location. What's there? What are all the features and what are all the attributes?" And then it responds. And of course, remember we talked last week. What has to happen is that request and response have to be understood by the client and the server. Okay. If I go to properties here, I can see that this is the URL of this particular map service. In other words, that is the address of that map service. That's its location on the internet. Now, if I go there, you're going to see something that you may not recognize. Okay, I got to sign in because this is behind ArcGIS's firewall. It's part of ArcGIS Online. But you're going to see this, okay? And it's basically telling you what's there. So there's a number of map services. I think we connected to, well, we connected to that coffee one. I don't even know what that one's. Oh, it's in USA MP _1 2016. Looks like it's that one. And then, so now there's a bunch of data, and this is giving us a description. Okay, this description was just entered into ArcGIS right here. If I go to File, Map Document Properties, if I put something here before I created my map service, it would automatically go into that location. But we'll get into how all that gets done when we create a map service. But here I can see all the individual layers. I can turn these layers on and off using requests, formatting requests. Here's the zip codes. And this is a list of all the fields in that layer. All right. So where does the program reside that handles the requests and shows this information? That resides on this one, the geospatial server. So geospatial server handles taking the data and serving that out on the internet. And so it has to have, it communicates with you through URLs. Okay, this is this URL, this Universal Resource Locator URL. Okay. Now, sometimes it sits behind another machine called a web server. Okay, and the web server is responsible for actually taking the requests. And what it does is, if a request comes in from ArcMap, we zoom, remember we did this last week with just the internet. But when the request comes in to PAN, okay, when we PAN, a request has to go out to get this new set of information. Okay? So that new set of information is retrieved from this URL, sent back, and put on there. Okay. That request can be made directly to the geospatial server, or sometimes it's made through a web server. In other words, the web server gets the request, and the web server is set up. In other words, it knows that it is standing in front of a geospatial server. So when it gets a request, it immediately forwards it on. Okay. In this class, we're not going to set up our web server to forward the requests on. Okay, when we set up our geospatial server 3 or 4 weeks from now, our geospatial server is going to handle the request directly from any client. There's no reason to have a web server unless you've got a big production environment, a separate web server, unless you've got a big production environment. What we will use a web server for is to handle all the other resources that need to be handled, that basically create the web client. You do not need a web server if you're using a thick client like ArcMap. Okay, you don't need a web server in that case because you can communicate directly with the geospatial server. You can have a web server, but you don't need one. You do need a web server if you are going to create your client as a web client. In other words, if you're going to create your own web page that's going to show geospatial information, then you need a web server to host that information. Okay. All right, so ArcGIS is one example. QGIS is another example. I wasn't sure if QGIS was installed. Has anybody used QGIS before? Okay, QGIS is an open source desktop GIS software. I didn't know if it was installed on these machines, so I didn't work it into the lecture. But perhaps I'll check, and then we can install it and utilize it, because it's just another package that works a lot like our GIS. It is a little bit kind of, it's not as polished because it is open source software. Okay. So thick clients like ArcGIS and QGIS get used to access data that's served up on a geospatial server and on web servers. But there's another niche that they fill for web mapping, and that is in data prep. It's very hard to set up a web mapping site. It's very hard to create one if you don't have some geospatial software to get your data ready. Okay, we're going to talk about all the things that you need to do to get your data ready as we progress through the course. But one of those things is that, really simple things. You need to get data in a certain projection, and that's hard to do without spatial software. GIS, thick client software. Another thing that you often need to do is that and this is the case with ArcGIS, the desktop software is actually the method for creating the online version. So you can't do one without the other. So I think that we've covered geospatial server pretty well. Let me see what else I had in here. Oh, that's the database server. Okay, response to requests for drawing maps, returning data, feature queries. Yes. All right, I'm going to cover each of those. Web server, often asked as the entry point. So that's the case where I said sometimes the web server can stand in front of the geoprocessing server and handle requests. One of the advantages of that is that sometimes in an enterprise site, it can do load balancing. So if it receives like 20 requests, you can set up multiple geospatial servers that all have access to the same data that can process those data individually, or those requests individually, and send them back. Okay, so if you have 10 servers set up that are pretty much clones of each other, the process comes into a single web server, and it can dispatch out 2 requests per service, and then send those all back up the line. But like I said, we're not going to set that up. Ours are all going to be on the same server. What we are going to do is use an HTML, is use it to host our HTML files, and that we are going to talk about today. Okay, a little bit out of order here. We're going to go back to databases and our file server. So that's right here on the chart. Database server, file server. And what I mean by and/or is that oftentimes you have one or the other. Sometimes you have both, but they serve a similar role. We talked a little bit last week about database management systems like Oracle and Postgres. That's what I mean by your database server. And one of the reasons why you'd want to set these up on a separate machine is that the software that runs these processes is often specialized, and you can make this computer optimized for running that software. And if you want to upgrade just this computer, you can upgrade that computer and then reconnect the geospatial server over to the upgraded machine, and then test it. And if it doesn't work, you can go back to the original one and fix it. So it makes it modular. Okay, but again, we're not going to have that luxury. We have a single computer to set this up on, and so we won't use database servers till the end. Actually, most of the time we will use a file server. In other words, when I say GIS file server, GIS files, what am I probably talking about? what are what are some formats for GIS data that you know of? Shapefiles. Yep. Yep. Shapefiles and various file geodatabase formats. Okay. So that's what I'm talking about. Most of our data will be like that. We will demonstrate a enterprise database server and utilize that by the end of the course. All right. Let's talk about all that. That's the same slide. Okay, some of the things, and this is from the reading, so let's look here. Whoops. All right, so we're going through this. One of the things I wanted to point out, rewinding just a little bit here, is that this looks a little different. I'm going to go back and fix this, but just in case you download it already and think that you might forget, there should have been a bullet right here next to web server. Okay, it almost made it the other version, the one that you downloaded, made it look like a web server was under geospatial server, but it's a separate thing. All right. Okay, and there's more information than what I just went over. Some good things in there. Actually, one of the things I just noticed that I forgot to mention. Oftentimes nowadays, it's increasingly common in production environments to not even own the hardware itself. Okay, this is the way our map servers are set up. I'll show you. So probably my largest project that I work on is this maps.coastalresilience.org, and there's lots of different sites. Here's the one that's closest. So this web map service, maybe I did show this last week. Sorry, this web mapping application. This is an example of a thin client. So we wrote the HTML and the JavaScript that runs this page, but none of it is hosted on computers that we actually own, meaning the university or our partner. The Nature Conservancy is our partner. We don't own those computers. We just buy a computer in the cloud, and they say, here's your computer, and we can connect to the computer, and it doesn't really matter where that computer is. Okay? So that's becoming increasingly common. So when you go out into your jobs, you can set up your own server, or alternatively, you can pay. Amazon is probably the biggest one, Microsoft, and Google, and there's a kind of a lot of little guys that are in the market. You can pay them to create a server for you, and you can choose the operating system. And when they're done creating it, it will have the operating system installed, and they'll give you credentials to connect to it, and then you connect to it. So here's an example of doing that. So here's a remote. I can remote desktop into. This is one of our servers in the cloud. So I can, maybe it's, I might not be connected to the, it's another one. I might not be connected to the VPN. In other words, I might not be connected right now and I have to sign in, but I can log in to that computer system and pretend as if I'm sitting at that terminal, and I can install ArcGIS. I can install software on those systems, and we'll actually do that. It's one of the modules that we'll do when we get to creating our own GIS servers. Together, we'll install ArcGIS server, the server software, using remote desktop, and set up our server. All right, so that's all that section. I think that's the only one I forgot, but you should go back and read that to get more information. Okay, so we demonstrated a thick client, but in this course we're more concerned with creating our own web maps, creating our own thin clients. In other words, using a web browser to access this data, and to utilize it and display it and make a map that people can use. The advantage of doing that is that we can make our application targeted. If you think about ArcGIS, it's powerful. It can do a lot of things. But when you open it up, you have no idea what's going on. Okay? You really choose your own adventure at that point. You can decide to do some analysis. You can do this. You can do that. When you're looking at web services, you're really limited because you can't see the data table or anything like that. Okay. Contrast that to a web map. The idea here, and this is another analogy with the cartography class, is that it is for a specific audience. Okay. So that's one of the reasons that you're all probably taking this course, is so that you can create these targeted apps for a particular audience. Yeah. Okay, so here we're going to talk about the elements of a web map. That's also in the thing here. These are a little bit shorter bullets, but one of the big considerations with web mapping is that, and you probably noticed this already when I added those data sets into ArcMap, is that because you're making a request to a server and getting a response back, you have to remember that you're introducing a few things. One of them is that there's this latency. In other words, a request is made and responded back to, and whatever processing happens on the server, it's hard to communicate how long that's going to take, because usually you just send a request and you kind of wait for it to come back. Okay, when it happens locally, lots of times the software developers that have made that software will program in things that say, okay, that's halfway done. You know, you've seen progress bars, right, in ArcMap. Okay, but that, if you want that sort of thing, you have to have you have to write code on both the client and the server, and it's not always dependable, because sometimes that information doesn't get transferred back, and there's really no way to tell whether or not it's ever going to come, or, in other words, if I'm the client, I don't know if it's ever going to come or if I'm still waiting. Am I still waiting? Like I'm stuck at 30%. Okay, and so you have that latency, and you've introduced this network interruption variable that doesn't exist locally. And you've probably all experienced things like that when you've used web applications, even like Gmail or whatnot. You press a button, what's happening? It's not doing anything. It appears like it's frozen. Well, the client is waiting for a response, but maybe that response is never going to come, and so it freezes. Okay? And the web is getting better and better at handling these things, but that is one of the considerations is latency and the connection. So web map speed is limited by how quickly the client can get a hold of all the resources required. And one of the biggest considerations that we're going to go through for the course, and we're not going to even touch this today, but later on, is in each step when we're building web applications, you need to think about performance. How well is this going to perform for one request? How well is this going to perform for 1,000 requests? And another rule is that web maps, I should say, never go faster than desktop maps. Oftentimes, it's the same code or very similar code that is running to create a desktop map. So if you hit add data in ArcGIS and you add 1,000 points to your map, and every time you zoom, it takes a little while to draw all those points, it's not going to be any different on the web, except for the only difference is your user's not going to see all those points come up individually. They're not going to see anything until all the maps are drawn. Bam, the JPEG gets created and sent across the wire. Okay, and so if it's taking a long time to draw in your desktop application and you want to make web data with that, there's some things you can do. Like, for example, you can make it into a tiled map service. Okay, there's drawbacks to that. The drawback is it's not dynamic. You can't change it every time there's a request. Okay. So anyway, those are some web map considerations. One way to get around this is to actually separate, and we talked about this a little bit last week, but now we're going to make this point, and now now you can understand why. It's not just cartography; it's also optimization in terms of how fast the network works. You can separate out these two concepts of a base map versus a thematic map. And your base map layers, the things that are in the background, those are very often tiled map services. They're created and they're very fast and to display, but they can take a long time to actually create because you only create them once, or you create them like once a year. You set your computer up. Okay, so the ocean charts have changed in this example here, maybe. Okay, we've got the ocean charts as the background layer here. The ocean charts have changed a bit. Somebody discovered a new seamount over here. Well, we can live for a year without that seamount showing up. So we just, once a year, we go in and recreate the data, and then the seamount shows up. There are, as the tools for these things get better and better, there are ways to, in ArcGIS now, to like draw a special area and say, only update the tiles in this area, only update the tiles in that area. So those are getting better, but that's the concept. Is we set up our base maps to be tiled map services that don't change, and our thematic layers, when they do change, we set those up to either be vector data, which we will start talking about next week, or we set those up to be images that are drawn dynamically every time the user accesses the map because they change. What do I mean by vector data anyway? What's the term vector mean in GIS for those? I know not everybody's taken a GIS class before. Right, points, lines, and polygons, right? So when I first started teaching this web mapping course 3 years ago, vector was not a big consideration in web mapping, but it is now more and more often. We can display our vector data right in a map. Okay, thematic base maps are almost always tiled. Thematic layers, change them. If they're going to change a lot, they should be tiled too. Sorry. If they're not going to change a lot, they should be tiled too. If they're going to change, particularly changing on less than a daily basis, they should be dynamic or they should be vector data. Whether or not they're vector or raster data kind of depends on how complicated they are. Okay, if they're very complicated, then there's a lot of vertices to pass through the internet. That's not going to work as vector data. But if there are a lot of points, maybe thousands of points, you're probably okay. And we'll talk about some thresholds next week when we talk about that. All right. So one of the things to remember is think of the map like a sandwich. I have a link in the reading that talks about that. That's down here. Okay, this is an old blog post from ESRI that talks about, whoops, trying to bring up the internet, which tries to bring up the internet as a sandwich. Okay, back in 2009, so it's like 6 years ago, which is forever in internet time, but this still applies. Okay, we can think about these layers. We've got to have labels. Sometimes we have to have labels. We want thematic data, and sometimes we have base map data. So oftentimes when these are all map services coming back as pictures, we put the labels on the top. Underneath we put the thematic layer, and underneath that the base data. Now some of this is changing for some data types. For example, if all we had was just the United States of America and its states, we might be able to get away with actually using vectors nowadays, especially if you had what do we call a high-speed internet connection. But if you wanted something more detailed, like all the counties, that would be hard to draw on as vectors. So that's a lot of data to pass through the internet. Depending on how complicated you want to draw the county boundaries. All right. Okay. We did this a little bit last week. So let's skip down. And we'll cover this a little bit better next week. I'm going to skip all the way to this example because we're going to look at the base maps and the overlaying data in some of the examples. So I've got this this Texas reservoir maps. One reason why I chose to show this one is that again, like the one like the Portland map I showed last week, this map is a good example of something that that you could work towards creating something like. Okay, so this is a good example of something that you could do as a final project for this course. Okay, so in this map, we can look at, if we go to more tools and developer tools, we can see, you know, as I move around here, I'm getting PNGs, and I can look and see where they're coming from. They're coming from Mapbox, which is a server, but it's still a PNG. It's still an image. So as I pan and zoom around, I'm going to this tiled map service. I can tell it's a tile almost always because in the URL you'll see something like this, where you'll see 3 numbers in succession. And usually what these mean are the zoom level and the row and column. So if you just think of the world on a flat map, not the globe, if you think about the world on a flat map, right? We could take the world, and that would be one map. And actually, using the spherical Mercator projection, if we divided it right in half, we'd have 2 squares. Okay, let me show you what I mean by this. So if I zoom this guy out, okay, this is okay. So sorry, 4 squares. So there's this one, this one, this one, and this one. If I divide it in half and divide it in half again, so I have 4 squares. So there are 4 tiles. So this would be, you know, zoom level 1. This would be row 1, column 1, row 1, column 2, row 2, column 1, and so on. So imagine that there's a dividing line here and dividing line here. Okay. So then, if I divided each of those up into 4 tiles themselves, in other words, if I cut down here and cut down here and cut down here and cut down here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'd have 16 PNGs that covered the Earth. And the reason why this is always a square is because you know, there's 180 degrees in each direction, and I'm using degrees here. So I cut those in half, and that's zoom level 2. And then I reference everything. I zoom in another way, and then now how many do I have? So I started out with 4. I go to 16. Next time I have 32, and so on. Right? It's always a power of 2 all the way down. It keeps doubling all the way down to, usually most web maps today go all the way to zoom level 20. So that's, I guess it would be, so when it's zoom level 1, it'd be 2 to the second, right? That would be 4 maps, 1, 2, 3, 4. So 20, it would be 2 past 20, so it'd be 2 to the 22nd. That's how many individual tiles there are. What is that? That's a huge number, right? Okay. That's how many rows and columns. So now, just to show this, if I zoom in to here, now look at the URL. So I've zoomed in. I haven't zoomed in all the way, but now I'm at zoom level 11. I'm at 528, 754. See, the numbers are getting bigger because there's more rows and columns. All right. Let's just refresh this page. All right, so here the thematic element are what? What's the thematic element here? Right, the reservoir levels or the thematic element. And, you know, we haven't progressed very far in the course, but I'm going to tell you right now that I can tell that these are probably actually vector data. Okay. One of the reasons I can tell is it's very responsive. When I highlight over it, you see what happens? I highlight over any of these reservoirs, what happens? Might be hard to tell up on there, but the outline becomes darker very quickly. Now, people did try to create effects like this so if all of this data was one JPEG that was coming over like as tiles, we could request a new JPEG every time we moused over an area, but we wouldn't know that we'd moused over. So there's no way for the client to know that we went over this circle. So we'd have to, every time we move the mouse, we'd have to be sending out an over circle, an over circle, an over circle, an over circle. I have to be sending that out. And when it said yes, it would have to send a new JPEG back. That's inefficient. So I'm pretty sure that these circles that we see here are vectors that have been drawn. I can inspect that, and it looks like, in fact, it is a marker. You can even, like, one of the things you could do, I could change. Of course, it's not. Maybe updated that one. Anyway, change the colors, do all sorts of things. But we'll get into that. Get into that later. So these are all vectors. I don't know if we could see for sure when that data comes in. It'd be coming in pretty close to the beginning. So these are all the network requests that have been made. And one of these is going to be to, oh, there it is, the reservoirs. And this is one of the things that we'll talk about next week. This is the actual reservoir data, okay? So at some point, somebody has used a GIS software package to convert these points, which might have been as a shapefile, you mentioned shapefiles before, converted them into a special format, okay? And that format is called JSON. And we'll use this next week. This might just look like a bunch of garbly-gook to you right now. And in fact, it's not meant to look like something a human can read. There are ways to make it look a little prettier. But it's data that the computer reads very well, okay? But it's very similar to a table. So there are coordinates associated. There are attributes associated. So that when I click on these reservoirs, I don't know where my, there we go. When I click on these, this information has been loaded up. The computer's, the client has it loaded up in its brain. And when I click on it, I'm just basically, I'm not asking the server again for the information. It's in the client because the client downloaded this whole set of information. So that's a vector format. Okay. All right. So the base map is what did you notice about this base map? Well, I already pointed out in the reading there, but is this base map very, very busy? No, it's just gray. It doesn't have, it has roads, which might be helpful, and it has labels, which are helpful. But it doesn't have a whole lot of information besides that. The water's blue, but it's a really light blue. It's not obtrusive. The map symbols are very bold. They stand out. They're a dark color, the thematic elements. So that's good. The map symbols are clear a little bit, what we call translucent, or they have an opacity value. that says that they're not quite transparent, but you could see through them. Okay, so that allows for what? Why would you want to make them translucent like that? Yeah, so you can see what's underneath, not just the labels, but also the other points, especially in like high traffic areas here. You can kind of see that these are stacked on top of each other, so you can visually tell there's a lot of reservoirs there. Whereas if, this one right here would be almost entirely obscured if you couldn't partially see through it. Okay. All right. Let's see. Okay, so that's the JSON file. We'll learn more about that later. Okay, we can click on these guys, get information. The information shows up over there. We'll learn how to do that. Take a look at the northern. Yeah, so here's another one. Head over to this other example. This one is a little more. It's a little more old school. That one's a very very modern approach using the vectors. This one is more like a GIS system where you turn on a layer, you turn on lots of other layers. It's not as focused. It has some GIS type operations. Okay, what I mean by that? Well, you can turn other layers on and off just like you can in GIS. What it does allow the user to do is make a map that may not be that pretty. Okay, we can add in lots of layers and make our map busy and lose focus to what it's about. So we're relying a little bit upon the user, but the user can make lots of different maps. So we can see all these different threatened species basically and where they are. So it's for a different audience. Okay, it's not as targeted, but it's still a web application that that you could build for this class. It would be a little bit harder, I think, to make something successful because you'd want to be able to do things like what is this value here? Okay, it's 4 species. Why isn't it the exact same color? Anyway, I don't see a way to do an identify, but we could do an identify. Okay. Anyway, that's an example of another one. The base map is the terrain of the Google Maps API. The tiles are being pulled from this CartoDB, which we'll talk about in the lab. Okay, yeah, this is what I was talking about. It appears there's a button for querying data, but I couldn't immediately figure out how to use it. Data sources, that's not it. Where was that? Anyway. Oh, search for location. That's search for location. All right, here's another one. This web map, and I would say this went beyond the above and beyond, but this web map was actually created as the final project for this course, and so this web map is set up kind of like that other web map in that it creates a map that has lots of layers. So it's like a GIS type map where you add in data. So these are all map services. We're looking here. We're seeing the images show up. So if I went here and open these up in a new tab, I'm seeing some of the small portion of that data show up. I know when you just look at one particular data set, it doesn't look like much, but these are those are icons. Anyway, some of the other resources that's loading. Okay, so we can look at all these data sets for Madison County. Again, it's more useful to somebody who's just interested in seeing what data is out there and inspecting the data rather than a targeted map that's interested in telling a story. By the way, in our coastal resilience application, we've got a mix. So in this one, we turn layers on to see things kind of like a GIS. But in these other applications, it's targeted. So here I'm looking at exposure to potential flood threats from hurricanes. And I can look at graphs that I'm interested in. I can look at census tracts rather than counties. I can look at the total value rather than percent total. So I'm kind of guided. I'm not turning on. Although what's happening in the background here is I'm actually just turning on a different layer. Okay, I have two layers, one for percent total, one for total value. And when the user toggles back and forth between these two, all that's happening is a different layer is turning on. So I'm just guiding the user to turn on a different layer. Okay. And that's oftentimes what happens in a web map. So let's say, okay, maybe this actually was another app that somebody built. So they found a flood scenarios that assumed a certain sea level rise would happen over time. So they had, okay, in 2025, this is the sea level rise. In 2050, this is the sea level rise. In 2080, this is the sea level rise. In 2100, this is the sea level rise. You can do it, you know, even if you don't like sea level rise, you can do this with population. This is the population projection for all these time periods. Okay. One way to set that up would be to have a web page where you just, you know, turned on, here's 2025, here's 2050, here's 20 whatever, okay? Another way to set that up would be to have some sort of radio button like this, okay? We'll talk about, this is a radio button. Would be to be able to set up and say, okay, I'm going to look at, you know, those three, and I'm choosing one at a time, so I don't have to turn the other one off. Something that might be even more effective, can anybody think of web pages that you've used before that might be more effective at showing a transition through time? Maybe I'm getting it. What'd you say? Yeah, a time slider. You've probably gone on to web pages where there's a little slider bar. In fact, there's one example on another site here. Okay, here's another example from the same family of places. So here I hit sea level change. Okay, I'm going to go to low, medium. There's no data there. Okay, so here I can go through time, and I can see how these things are changing. So this is something that that we could cover, and you can see also that there's data changing down here in this section. Okay, that data is changing on the map, and the data is showing up here. All right, so these are all examples of different web maps. And one of the reasons why I'm showing you these is that one of your assignments is to kind of start looking at web maps and noticing how they present the data. Do they all? They don't all operate like GIS websites where you turn layers on and off. Okay, because if it's just turning layers on and off, it's just like a desktop app. It might be powerful. It might allow us to make all sorts of different kinds of maps, but it's not targeted. It's not telling us a specific thing that we can do. So here's some other examples, and so one of the assignments, which we'll go through in just a second, is to go through and look at these and kind of start critiquing them so you can get a good idea of something that you might want to do and how you want to do it. Because you may decide, hey, I want to put a slider on. We may not cover sliders unless somebody says, hey, I'd like to put a slider on my web page. You know, so there's all sorts of directions we could go, and that's why I want you to start looking at web apps and kind of formulating how your app's going to be. And then I can also kind of, again, temper expectations and say, well, that's great, but we might want to limit the scope just a little bit for an introductory course on this subject. Okay, so it's 6:15. I'm gonna wrap up, and that's gonna be it for the lecture part. The lab part's gonna be a little bit longer today, so we're still gonna get all our contact hours in. But let's take a 15-minute break. Another thing I'm going to do is stop the, I think it cut the video short, so I'm going to try to make the video separate each time. Let's take a 15-minute break, come back at 6:30, and I'll introduce the two assignments that we have for this week. That'll take about 20-30 minutes, and then I'll introduce just basic HTML, CSS, and JavaScript. That might take close to an hour. So anyway, we'll proceed from there. All right?
So quick question.
Sure.
So difference between a database server and a file server, is it just that the database server is using software to go into the database and extract the information, or is this file server is more of a repetition? We have databases at work, and then we also have what you would say, like, I can see where a file server would come in. We're pulling down the ocean files for today and the next forecast to get written over tomorrow when new model runs come out and replicate and replace them. Whereas databases are kind of static.
Yeah, that's a great point. So, for the purposes of what I'm talking about, a file-based system, the files are just there, and there's no software that's managing those files.
So that's still a different action that's going to be taken place.
Yeah, the GIS software connects directly to the files, and when it's a database server, sometimes the GIS can connect to the database, and the database software is there to kind of ask additional questions. So you can use GIS software and say to formulate a query and say, yeah, but you can also use the database software layer to make a query into the database and say, okay, show me only the things that meet this certain criteria. So it's another layer of software that manages the data. And that additional layer of software it does complicate things a little bit, and there is some latency involved with having a database server, but usually that can be minimized so much that the benefits, which are you can have different versions, like you can keep track of version A and version B, version C better. It can also sometimes perform the query in a more optimized way than the GIS software could. But in a situation where you don't need to take advantage of versioning or the additional querying, it is actually faster to use a file-based system. Multi-user is another advantage. So you can have multiple users editing because of versioning. I guess that's related. Whereas in a file-based system, if you try to, you've often probably seen that when you have something open in two programs, try to save some GIS package, some GIS file, they'll say, hey, there's a lock, a schema lock.